Okay.
All right. Number 19. An inscribed angle has its vertex on the circle. So a possible example here would be CDG. That is not the only inscribed angle, but that one has its vertex D on the circle. So angle CDG would be an example of an inscribed angle. A central angle has its vertex at the center. So angle HAD or DAF, those would both be central angles. A tangent line touches the circle in exactly one place. So this line right here, that's only touching the circle right here, would be an example of a tangent line. I could call that line BH, HJ, or BJ. I'm going to go ahead and call this one BH. A secant line goes through the circle. It does not stop at the circumference. It goes through on at least one side. So BD, or I could call that CD. Yes, you may. If this diameter HF were to continue, even if it was only on one side, that would be a secant. It doesn't have to go through the circle on both sides to be considered a secant, as long as one of the ends of that line or line segment or ray extends beyond the circumference. That would count as a secant. Point of tangency. This is the point where the tangent line touches the circle. So point H would be our point of tangency. And a chord stops at the edges of the circle. So CD would be a chord, and that's a segment, not a line. DG would be another example of a chord. HF would be an example of a chord. Notice chords are always segments. They get a dash over the top, no arrows. Secants and tangents can be either segments or lines or rays, but a chord is only ever a segment. What else would you guys like to see? 21, absolutely. Write each radian measure in degrees. So we take the radian measure that's given. In this case, on part A, that'd be 3 pi over 4. And we multiply that by our conversion factor, which is 180 degrees over pi. So my pi's cancel out because I have one on top and one on the bottom. The 3 in my numerator will only distribute to the 180 in this numerator. What is 3 times 180? $540. Down in the denominator, this 4 is still here, so that becomes the denominator here. And then I need to divide 540 by 4. 135, and that would have degrees with it. Because you have one on top and one on bottom, kind of like how if you do 2 divided by 2, that would simplify to a 1. Pi divided by pi simplifies to 1. Not 1 pi, just 1. 20 as well? 22, yes. Do you guys want me to do part B on this one? Yeah. Okay, let's do part B and then I'll go do 22. 2 pi over 3 times 180 over pi. My pi's cancel out. 2 multiplies to the 180. What is 2 times 180? 360. So I have 360 degrees in my numerator and a 3 in my denominator. What is 360 divided by 3? So 120 degrees. Yes. To do number 20, you use that exact same conversion factor except flipped over. So if you're going from degrees into radians, then pi goes in the numerator and the 180 goes in the denominator. But it will always be pi and 180 in a fraction together when we're going between radians and degrees. Number 20? Yeah, I can do number 20. And then we'll go do 22. All right, so 60 degrees times, since I want to go into radians, my pi needs to be in my numerator. So now the degrees are going to cancel out because I have degrees on top and degrees on bottom. This is 60 over 1. So I multiply the 60 to the pi and the 1 to the 180. So I have 60 pi over 180. And now we need to reduce the fraction down. 60 ends in a 0, and 180 also ends in a 0, which means what has to go into these two numbers? 10. Let's divide them both by 10, and then see if we can reduce beyond that. 60 divided by 10 would be 6, so I have 6 pi in my numerator. 180 divided by 10 is 18. Can I reduce that anymore? Is there anything that'll go into 6 and 18? 3 or 6. If you divide it by 3, you're just going to have to reduce one more time after that. But there's nothing wrong with choosing a smaller number to reduce by. So this would give me pi over 3. Because 6 divided by 6 is 1. So I have 1 pi, or just pi. For part B, 275 degrees times pi over 180 degrees. 275 is over 1. My degrees cancel. 275 multiplies to the pi. 1 multiplies to the 180. So 275 pi over 180. What can go into both 275 and 180? 5. So we're going to divide top and bottom by 5. What is 275 divided by 5? 55. So 55 pi in my numerator. What is 180 divided by 5? 36. Can we reduce this any more? What are the only things that go into 55? 5 and, not 1. 5 times what gives me 55? So 5 and 11 go into 55. Does 5 go into 36? Does 11 go into 36? That's how I know for sure that this does not reduce any further. All right, number 22. We need to find the value of x, the measure of arc BEC, and the measure of arc DA. Well, the only place x is right here, which goes with this arc. So I'm going to need to figure out how big that arc is so that I can set the expression equal to that value. Looking right here, DB cuts my circle exactly in half. It goes through the center and it divides my circle in half. So what would we call segment DB? Goes through the center. Arc DEB would be a semicircle. Diameter. So because DB is a diameter, arc DEB would be a semicircle. And a semicircle is how many degrees? 180. Well, I know how big this arc is. It's 56, and this one here is 57. So how could I figure out the size of this arc? Add those two smaller ones and minus it from 180 because I have a semicircle. So 180 minus 56 plus 57. What is 56 plus 57? 113. So 180 minus 113 would give me what? 67 degrees. So this arc here is 67 degrees. So to find x, we're going to take 2x minus 7. And we're going to set that equal to 67. The arc is 67. The arc is also 2x minus 7. So those two things have to be equal. We're going to add 7 to both sides. 2x equals 74. And then we divide both sides by 2. X is 37. Arc BEC. Let me find a good color for this. Here's B. Then we have to move towards E, so I have to go this way. And then all the way around to C. So this arc here is what I need to find the measurement of. That's almost the whole circle, right? We've only left out one little chunk that's how big? 99 degrees from right here. So to find this, I can take a whole circle, 360, minus the one arc that we're leaving out, which is 99 degrees, and that would give me what? $261 degrees. And then we need arc DA. Well, here's D. Here's A. So that's made up of this 67 degree arc and this 56 degree arc. So we're going to do 67 degrees plus 56 degrees. And we get what? 123 degrees. All right. What do you guys want to see next? You said 24? Absolutely, we can do 24. So on number 24, it says, assuming lines that appear to be tangent are tangent. How many places does a tangent line hit a circle? We did this on number 19. How many places does a tangent line hit a circle? 1. This tangent line right here hits the circle right here. And this tangent line right here hits the circle right here. They come from the same point. They have the same origin here. That means that these two tangent lines are congruent to each other. So to find the value of x, we're going to take those two expressions, 2x minus 5, and set them equal to each other, x plus 6. They are the same size, they are congruent because they come from the same point, and they are both tangent to the circle. First thing we need to do now after we set up our equation is get our x's on the same side. So I'm going to minus x from both sides. What is 2x minus x? 1x. So x minus 5 equals 6. And then we plus 5 to both sides. So how big is x? 11. All right, what else? $23? Absolutely. Find the value of x again. So we have this angle right here. This is angle QSR. That is inside my circle, but it's not right at the center, so it's not a central angle. The measurement of an inside angle is equal to half the sum of the two intercepted arcs. And these two intercepted arcs, well, one of them would be this arc right here, QR, and the other arc would come from the vertical angle portion over here, arc PC. So we're going to take our angle, 65 degrees. That's my inside angle, so it goes over here on this side by itself, equals 1/2. And then I add those two arcs together, 50 and 20x. I need to get rid of that fraction that's there in front of the parentheses. How do we get rid of fractions? Times both sides by 2, absolutely. Let me scoot this up a little higher here. So we're going to multiply both sides by 2. That means I need to do 65 times 2. What is 65 times 2? 130. So I have 130 equals 50 plus 20x. I don't need the parentheses anymore because there's nothing else on that side. So now I'm going to minus 50 from both sides. What is 130 minus 50? 80. 80 equals 20x. And now we divide both sides by 20 to isolate the x. What is 80 divided by 20? So x is 4. What else do you guys want to see? Another one with a formula similar to this one? Number 28 has a similar but different formula. So why don't we go look at number 28 then? Number 28, where's the angle? Inside, outside, or on the circle? Outside. If it was inside, then my angle is half as big as the sum. I add my two intercepted arcs together. When we have an outside angle, my angle is half the size of the difference of my two arcs, arc minus arc. And it has to be the two intercepted arcs. So I'm looking like this. Here's one intercepted arc, and here's the other intercepted arc. Yep. So my outside angle is called angle F. So I'm going to replace this right here with the measurement of angle F equals 1/2. Now when we do arc minus arc, it has to be bigger minus smaller. So bigger arc, 167, minus smaller arc, 69. What is 167 minus 69? 98. And what is half of 98? 49 degrees. So angle F would be 49 degrees. So inside angle, you add the arcs and then cut them in half. Outside angle, you subtract the arcs and then cut them in half. No, an inside angle, you plus the arcs together. Outside angle, you minus the arcs. What else would you guys like to see from Module 10? Number 24? Or sorry, number 23? Absolutely. Yeah, I can do 25. You good, Carla? Okay. You're welcome. 25. We want to find the measure of angle SXW. So this angle right here is what we're looking for. The arc that it is intercepting is this one right here, SVW. SXW has its vertex on the circle. That makes it an inscribed angle. So the measure of angle SXW is equal to half the measure of arc SVW. So we're going to have to figure out how big arc SVW is. Let's look at the information that they've given us to work with. This angle right here, WSX, is 36 degrees. And it is intercepting this arc right here. WX. It is twice as big. So since it's 36 degrees, we do 2 times 36 degrees. We get 72 degrees for this arc here. And then we have this angle, SWX. It's 64 degrees. And it is intercepting this arc right here. Since it's also an inscribed angle, the arc is twice as big as the angle, so 2 times 64 degrees. This arc is 128 degrees. All the way around a circle is how many degrees? 360. Well, now that I know those two arcs, the only other thing up there is that orange arc. So I can figure out how big the orange arc is by taking 360 and minusing those other two arcs that we have, the 128 and the 72. What is 128 plus 72? It's 128 plus 72. 200. And what is 360 minus 200? 160. So this arc here is 160 degrees. So the measurement of angle SXW is half of 160 degrees. Well, what's half of 160? 80. All right. 26 or 27, anybody? 26, sounds good. What kind of an angle is angle N? It's got its vertex right on the circle. What do we call that kind of an angle? An inscribed angle. The inscribed angle is half as big as the arc that it intercepts. Angle N is intercepting this arc right here where my question mark is. So the measurement of angle N is equal to 1/2 the measurement of arc ML. Well, we know that angle N is 37 degrees. So 37 degrees equals 1/2 measurement of ML. How do I get rid of the 1/2? Multiply by 2 on both sides. It's going to cancel out my denominator here. What is 37 times 2? 37 times 2, yeah. 74. So 74 degrees is equal to the measurement of arc ML. All right, that was the bell for the halfway point. So we are going to switch gears and go to module 11. Before we do that, did anybody want to see 27? Yeah. All right, since we're right here. Circumference of a circle is 198 inches. Well, the formula for circumference is equal to 2 pi r. So I'm going to put 198 in for the circumference equals 2 pi r. They just asked me to find the radius here. I don't need to find the diameter, so I'm going to divide both sides by 2 pi. Remember, if you're on one of my yellow calculators, if you don't use the fraction button, you have to put parentheses around that denominator, or it will not give you the right answer. What is 198 divided by 2 pi? Did you put parentheses around the 2 pi? 198 divided by 2 pi, and you have to put parentheses around the 2 pi. 31.513. And we would put inches with that because the circumference was given to us in inches. Please, please, please remember that if you are dividing by something with pi, you've got to put parentheses around it, or else it will give it to you wrong. All right. Let's switch over to Module 11. Hold on. There was only one more question in Module 10, right? Did you guys want to see 29? Yep, I'm seeing some yeses. So we'll go over it real quick, and then we'll go do Module 11 stuff. 29. PA and PB are tangent to the circle. Name the two right angles. So here's PA. Right here where it hits the radius of the circle, it makes a right angle. So PAO is a right angle. PB hits my circle right at B. So PBO is my other right angle. And then it says if PA is 24 inches, hold on, before I read the next part, what do we know about two tangent lines that come from the same outside point? They're congruent. So PA is the same size as PB, so this is also 24 inches. It says that OB is 12 inches. So this segment right here is 12 inches. What do we know about all the radii in a circle? They're congruent. So OB is exactly the same size as what else? OA. 12 inches. They want us to find PO, this right here. Well, look what we just made here. A right triangle. What can I use to find missing parts of right triangles? Pythagorean theorem. A squared plus B squared equals C squared. C has to be my hypotenuse. What's the hypotenuse of this triangle? PO. That is opposite my right angle. So I'm going to put PO in the place of C. So A and B have to be 12 and 24. Order does not matter. So we have 12 squared plus 24 squared equals PO squared. What is 12 squared? 144. 24 squared? 576. We need to add those two together. What do we get when we add those two together? 720 equals PO squared. And then we take a square root of both sides. That's going to cancel out the squared on PO. Let's go ahead and do this one in decimal form. 26.833, 26.832, depending on where you round. And we would put inches with that. So 26.833 inches. If the question asked for it to be in radical form, reduced radical form, that would be 12 square root of 5. If you guys want to see how to get 12 radical 5 as the reduced radical form, I'm happy to go over that with you guys when we get to the D lunchtime if you want to see that in detail. All right, Module 11. What do we want to see? Number 30? Absolutely. A trapezoid has an area of 85 feet squared. If the height is 5 feet, and one base is 14 feet, find the length of the other base. If you do not have the formulas from 11A and 11B written down on your cheat sheet, you are doing yourself a disservice. You are hurting yourself on the final exam. I would highly recommend getting all of the area formulas: trapezoid, circle, square, rectangle, regular, polygon, diamond, like a kite shape, a rhombus. Make sure you have all of those. That was on the very last page of our notes for 11A. You also want to make sure that you have all of the notes for 11B. That was on the little half sheet of paper that you guys could use on the exam, and I have extras of that over there. All right, we're going to put 85 in the place of the area, so 85 equals 1/2, and then we have a height of 5, and then we have base 1. We're going to put 14 in for one of those bases, and then we're going to leave the other one as a variable. I'm going to leave it as base 2. I've got two different ways that I could get rid of that 1/2, get rid of the fraction. I can either figure out what half of 5 is. That's going to give me a decimal because 5 isn't even. The other way that I can get rid of that fraction is by timesing both sides by 2. So that'll get rid of my denominator. What is 2 times 85? 170. So I have 170 equals 5 times the quantity 14 plus base 2. How do I get rid of this 5? I have to divide it to get rid of multiplication. We're going to divide by 5 on both sides. That'll make my 5 cancel out here. What is 170 divided by 5? You said 134? 134 equals 14. Wait, you said 134? 34, thank you. I heard the wrong thing. 34 equals 14 plus base 2. I don't need the parentheses around the 14 and the base 2 anymore because there's nothing else on that side anymore. And then we subtract 14 from both sides. We get 20 for our second base. What kind of units should go with that 20? Feet. 20 feet equals base 2. All right. What else would you guys like to see? 34? Absolutely. All right, so number 34. Oh, that's 36. I went too far. There's 34. To find the arc length of a sector, the arc length is equal to the fraction of the circle that we are looking at times 2 pi r. Well, the fraction of the circle that we are looking at is 75 degrees out of how many total degrees in a circle? How many total degrees? We have 360. So 75 out of 360 times 2 pi times our radius of 14. And then we pop it into our calculator. And what do we get? Mm-hmm. Yep, 18.326 meters. And then area for a sector, we still want the fraction of the circle that we're looking at. But now we're talking area, so now it's pi r squared. The fraction of the circle that we're looking at did not change. We're still looking at 75 degrees out of 360 degrees times pi times our radius of 14 squared. What do we get for the area? 128.282, and that would be meters squared. What else would you guys like to see? $35? Absolutely. So we want to find the area of the sector. I know how big the base is, that's 34.5, but I don't know how big the height is. So I can't use 1/2 base times height. This is 1/2 AB times sine of angle C. So here's one of my sides. Let's go ahead and call this side A. My other side that I know is this one right here. So let's call that side B. And then I need the angle in between them for C. What is the angle in between those two? 37. So here's angle C. So area is equal to 1/2 times 34.5 times 20.8 times the sine of 37 degrees. No adding here. The only area formula that has adding in it is my trapezoid. What do we get for the area of this triangle? $215.931. And they didn't give us any kind of units, so we don't put units, or you could write units squared. Up to you. What else would you guys like to see? There are three more problems that are from 11A, and then the remainder of the problems are 11B. Yes. 36, absolutely. 36 is the first problem on the review from 11B. It says find the total amount of square feet that needs to cover the silo. He's going to paint the outside of his silo. The bottom base of the silo is on the ground and would not be painted. Well, if we're looking for total square feet, that is surface area. And what are the two shapes making up this silo? A cone and a cylinder. So we need the surface area of the cylinder together with the surface area of the cone. Surface area of the cylinder, 2 pi r squared plus 2 pi r h. This 2 pi r squared here, that's my two bases. And 2 pi r h is the lateral area. For the cone, we have pi r squared plus pi r cursive L for my slant height. Pi r squared is the area of my one base. And pi r times slant height, that is the lateral area of the cone. Now I need to figure out which pieces of this are actually on the surface of this object and would be covered with paint. Would we be painting the base of the cone? No, that's on the inside of the silo, not the outside. So we don't need the base of the cone. And then we've got two bases on the cylinder. We've got a base up here and a base down here. Would we paint this base of the cylinder? What about this base down here on the ground? What's it say? Yep, it says the bottom base of the silo is on the ground and would not be painted. So are we painting either of the bases on the silo? No, not on the cylinder. So 2 pi r squared gets thrown out. All right, so to find this area, 2 pi times my radius. Well, it shows me here that the diameter is 8 meters. So my radius is going to be 4 meters. So 2 pi times 4 times the height of the cylinder. What's the height of the cylinder? 14. And now plus, we're leaving out the base of the cone, but we need pi times our radius of 4 times our slant height. Well, this would be the slant height here. I'm going to need to use Pythagorean theorem to figure that out, but that means I need to know what the height of the cone is. The height of the cylinder is 14 meters, and the height of the whole thing is 20 meters.
That's 6.
So we have 6 left over, 6 meters for the height of the cone. So we're going to use Pythagorean theorem to find our slant height. A squared plus b squared equals c squared. My slant height is the hypotenuse, so we're going to put cursive L in the place of c. 6 and 4 go in the place of a and b, doesn't matter which is which. So I have 6 squared plus 4 squared equals my slant height squared. So 36 plus 16 equals slant height squared. What is 36 plus 16? 52 equals the slant height squared. We take the square root of both sides to isolate the slant height. Is the square root of 52 a nice, pretty whole number? No. Then we're going to leave this as radical 52. So pi times 4 times the square root of 52. All right, let's find the lateral area of the cylinder first. 2 pi times 4 times 14 comes out to be what?
351.858.
Yes, 351.858. Plus the lateral area of the cone, pi times 4 times radical 52. $90.617. Then we add those two together to get our total surface area of 442.475 meters squared. Part B, it's asking the total amount that will fit inside. So what am I asking for there? Volume. So I need the volume of the cylinder plus the volume of the cone. To find the volume of the cylinder, that's pi r squared times the height of the cylinder. The volume of the cone is 1/3 pi r squared times the height of the cone. The radius for these two is the same. It's 4, so pi times 4 squared. And what was the height of the cylinder again? For the cylinder? 14. Let's go ahead and find that volume first. Pi times 4 squared times 14. What do we get? I think it would round up to a 1.7, yeah. So 703.717 plus, now we need the volume of the cone, 1/3 pi times the radius of 4 squared times the height of the cone. What was the height of the cone? 6. So 1/3 times pi times 4 squared times 6. 100.531, giving us a total volume of 804.248 meters cubed. All right, what else would you guys like to see? Got 31, 32, 33, 37, and then the entire back page, 38, 39, 40, 41, 42. 40? Absolutely. Find the volume of the square pyramid. Our formula for the volume of a pyramid is 1/3 times the area of the base times the height of the pyramid. And what shape did they say the base was? A square. How do we find the area of a square? Side squared. How big are the sides of the base? $11. So 1/3 times 11 squared times the height of the pyramid, which is 10. So 1/3 times 11 squared times 10, and we get what? Should be smaller than that. She said 600 something. Yep, 403.333 kilometers cubed. All right, what else? Which one did you say, Kaylin? 31 and 41? Right, let's do 41 since we're sitting right here, then we'll go back and do 31. How much paper means surface area? And then it says that it has an open circular top, so no base on this cone. My surface area formula for a cone is pi r squared plus pi r times the slant height, but we're not going to do the base, so we get rid of pi r squared. So just pi r L. Yep, surface area of the cone is equal to pi r squared plus pi r and then cursive L. We're crossing out the base because it said it has an open circular top. So there is no base. So pi times, how big is the radius of this cone? 3. From here to here would be 3 meters. So pi times 3 times, how much is the slant height? 7.6 is our slant height. So then we grab our calculators, pi times 3 times 7.6. 71.628 meters squared. All right, we're going to go back to 31 now. And this will be the last one that we have time for as a class. We might even run a little bit past the D-lunch bell, but I do want to finish this one up because this is an important one. Given a regular octagon with a radius of 5 inches, Draw the radius and then find the perimeter and area. A radius on a polygon goes from the center to a corner. So here's a radius. I'm going to go ahead and draw in another radius right next to it, creating an isosceles triangle. We need to find the perimeter, which means I need to find the length of one of the sides. So then I can multiply that by how many sides I have in my octagon. In order to find the length of the side, I'm going to need to find the measurement of the central angle. How do we find the measurement of a central angle? Yes, 360 divided by the number of sides. What is 360 divided by, wait, how many sides do we have? 8 sides. 45 degrees. So my central angle here is 45 degrees. To find this half side length, I'm going to need to take my isosceles triangle and cut it in half. That dashed line there is the apothem. It's going to make a right angle with my opposite side. And so now we are going to focus on just this little right triangle here. I'm going to draw that off to the side. All right, so here's my right angle. This is my apothem. The radius, which I have in blue here, is 5 inches. And this piece down here is half the side length of the octagon. What is that apothem doing to my central angle? It's bisecting it. It's cutting it in half. What's half of 45? 22.5. So this is now a 22.5 degree angle here. We're going to stand up at that 22.5 degree angle, and we're going to label our sides. What is the hypotenuse of this little triangle here? 5. That radius is my hypotenuse. This right here is which side of the triangle? The opposite. I would have to go from where I'm standing and walk through the triangle to get there. That makes it my opposite side. And so right next to me here, this apothem is which side? That's my adjacent side. Remember, adjacent means next to or touching. To find the perimeter, we're going to need half the side length, so then I can times it by 2 and find the whole side length. And I have the hypotenuse. Time for SOHCAHTOA. Which one of these lets me use hypotenuse and opposite? The first one, sine, yes. So we're going to do sine of our angle, 22.5, equals my opposite side, which is that half side of the octagon, over the hypotenuse, which is 5. How do I get rid of the denominator? Multiply. So we're going to times both sides by 5. It's going to cancel my denominator here. So now I need to put 5 times the sine of 22.5 degrees into my calculator. .913 is equal to half the side of the octagon. So how do I make it a whole side then? Times it by 2. Yes. 3.826 is equal to the side length of the octagon. So now how do I find the perimeter then? Times it by 8. Number of sides times the length of each side. We have 8 sides that are each 3.826, which gives us a perimeter of how much? 30.608. Would we have units with that? Inches. So here's my perimeter. 30.608 inches. And now we need to find the area of this. Well, the area of a regular polygon is 1/2 apothem times perimeter. I know how big the perimeter is, but I don't know how big the apothem is. The apothem was my adjacent side over here. And I'm going to keep using the hypotenuse because that was a nice whole number. That's easy to work with. Which one, sine, cosine, or tangent, will let me use the adjacent and the hypotenuse? Yep, cosine. So cosine of 22.5 degrees is equal to the apothem divided by the opposite side. Sorry, not opposite side, divided by the hypotenuse, which is 5. So then we times both sides by 5 again. So now I need 5 times cosine of 22.5. How big is our apothem? 4.619. So that's what we're going to substitute in. Area is equal to 1/2 times 4.619 times the perimeter that we already found, which is 30.608. And that gives us an area 70.689, and that would be inches squared. Yep. Right. I am posting videos from every single class period today since there are so many questions here and we didn't have a chance to get through them all. If you have a question about one that I did not go over, hop into Canvas and see if it's in either the first or second period video, or you can come up to my desk and I'm happy to go over it with you. Tonight, while you're studying and finishing up your cheat sheets, you might check out those videos. I've posted videos every single day of the review, and it's got exactly which problems have been gone over.